Hello everyone, I am Victor, and today's video will be covering maximal flows in optimization and spreadsheet modeling. This video is for my optimization and spreadsheet modeling course taken at Rutgers University, Camden. I'll be referencing and covering a research paper named A New Maximal Flow Algorithm for Solving Optimization Problems with Linguistic Capacities and Flows. This paper is written by Muhammad Akram, Amna Habib, Tofigh Allahviranloo. Maximal flow problems are among the most widely applicable problems. For those who are unaware of what a maximal flow problem is, essentially it is trying to find the largest flow that is able to be transported from one location to another. These could also be referred to as vertexes. Some examples of real-world applications of this problem include, but are not limited to, project plans, queuing plans, pipeline systems, computer networks, and so on. This problem has many applications and is something that is needed to extract the full efficiency of the products and services we use and provide. Moving back to the paper covers the idea by starting with the abstract and introduction, bringing the idea to life. Then, it dives into the background and other work prior leading up to this point, giving credit and showing the process of learning how to do these types of problems over the years. This also includes notes about how the processes we have evolved and why they are significant in this area, and the reason why they're in the paper in the first place. After the background, the paper moves to the findings of the work of the authors that they have compiled, along with the reason behind the paper, the methods being presented, and things of that nature. It dives deep on its practicality to world problems and systems. And then after all this preliminary information, the paper speaks on the structure and foundation for the paper and the paper's problem statement. It then cuts into the data, proving their work against the problem statement with examples, graphs, equations, and numbers. Throughout, it speaks on its issues, case studies, complexities, and so on. Overall, the paper covers defining trapezoidal Pythagorean fuzzy numbers, or TRPFNs, and it also covers the ranking and defuzzification of TRPFNs. And this in turn makes a theoretical framework for a new algorithm to solve optimization problems with the Pythagorean fuzzy information. This is done by the considerations and respect to the flows themselves and linguistic capacities. The paper then provides examples of this in action with researching the maximal flow of a water pipeline network. A lot of these problems are graphed, and you'd start with the source and sink nodes, and these pipes themselves, if we're using the water pipeline problem, could vary in size, flow, capacity, and speed, which need to be inserted into the model to account for uncertain events or information. This is a new type of modeling called intuitionistic fuzzy set, which is to consider the certain and the uncertain. And this can allow to balance and model the uncertainties more effectively. And this information is based on the research paper, A New Maximal Flow Algorithm for Solving Optimization Problems with Linguistic Capacities and Flows, with what it covers and how it is significant to optimization and spreadsheet modeling. Thank you, and I am Victor.